This is the seventh behavioral design pattern from the famous Gang of Four book. This one is called observer pattern, and it is a pattern you use when you want to define a dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. I will start with a quick summary of what we are trying to accomplish with this pattern. The observer pattern is a good choice when you are trying to accomplish the following. Your objects can be grouped in subjects with a fluid internal state and observers that must be notified when subjects change state. The number and type of observers can change dynamically at runtime. You want loose coupling between subjects and observers to aid scalability. Let's go through the points one by one. So, in this situation, you have an application architecture with one or more subject objects with fluid internal state, meaning the state can change at any given time. But you also have another group of objects that need to be notified whenever the subjects change. The easiest way to do this is by simply referencing the objects directly. Every subject references every observer. Whenever a subject changes, it calls the observers directly to notify them of the state change. But there are two problems with this solution. First, you need to know every possible combination of subject and observer at compile time. The solution breaks down if observers can be dynamically added or removed at runtime. And second, you are creating a very tight coupling between the subjects and the observers. This restricts the scalability of your architecture. The observer pattern solves these problems. It provides a way to dynamically connect subjects and observers together. Instead of statically referencing the objects at compile time, the pattern allows you to do this at runtime using attach and detach methods. There are two ways in which subject objects can broadcast a change in their internal state to other parts of an application. The push model, where subjects directly call all observers and notify them of the changed state, or the pull model, where subjects signal that the state has changed and observers then retrieve the changed state themselves. The observer pattern is a pull model, and it offers a number of benefits over the push model. First of all, the observer pattern is more flexible than the push model. In the push model, the subject needs to know exactly which observers need the new state. But in the observer pattern, the subject only signals that new state information is available. The observers then decide on their own if they need to retrieve it or not. The pattern puts the code that decides whether to retrieve the new state information exactly where it belongs, in the observers. This also makes the pattern much more scalable than the push model. When you're adding new types of observers at runtime, all you need to do is register them with the subject to make them work. Contrast this with the push model, where the knowledge on how to deal with new types of observers needs to be added to the subject. The observer pattern creates a loose coupling between subjects and observers, and this makes the application architecture much more scalable. The observer pattern also has some disadvantages over the push model. For starters, it is slightly less efficient. In the push model, the observers receive both the notification of a change and the new state data in a single method call. In the observer pattern, however, the subject only sends a notification. It is then up to the observers to retrieve the new state information. This requires one extra method call. Another disadvantage is that the pattern has a fairly narrow focus. It cannot deal with subject state that rapidly changes or observers listening to multiple subjects. If these scenarios occur in your application architecture, you are going to have to modify the pattern. And finally, the pattern may introduce a memory leak. The subject keeps references to all active observers, so an active observer can never be garbage collected, even when it goes out of scope. You have to explicitly unregister the observer to enable it to get garbage collected. If you forget this, you will clutter the heap with stale observers. Here is the UML diagram of the observer pattern. So here's how it works. The subject is in the top left-hand corner of the diagram. There's an abstract base class called subject that declares three methods: attach, for attaching an observer to the subject; detach, for detaching an observer from the subject; and notify, which will notify all attached observers. There's also a concrete subject class called concrete subject. The class declares an internal state in a field called subject state, and it contains a method called getState for retrieving the state. The observers will call this method directly to retrieve the new state. The observer is in the top right-hand corner of the diagram. The abstract base class, observer, declares a single update method. The subject will call this method directly to notify the observer that its state has changed. There's also a concrete observer called concrete observer. The class tracks the subject state in an internal field called observer state. The class also implements the update method. The method calls the subject's getState method to retrieve the new state information and stores it in the observer state field. So, here's how the complete sequence works. Any observer that wants to be notified registers itself with the subject by calling the attach method. When the subject changes, it will call the update method on all attached observers. Each observer will then call the getState method to retrieve the new state and store it in the object state field. This sequence ensures that all object state fields stay in sync with the subject state field. The .NET Framework has a specific implementation of the observer pattern that is pervasive throughout the entire base class library. The framework uses events to implement the pattern. Here's how that works. Events are dynamic method references. You can point an event to a specific method, and when you call the event, you are actually calling the underlying method. To implement the observer pattern, the first thing you need to do is declare a delegate with the correct event signature, like this. The nice thing about this signature is that the first method argument clearly identifies the subject, so there is no need for the observer to keep a reference to the subject. And the second method argument is an optional data value. You can use this argument to store the subject state. Do you remember the disadvantages of the observer pattern? It's less efficient than the push model, and it's hard to have an observer listen to more than one subject. Well, this specific implementation solves both problems. Okay, the next thing you need to do is declare an event, like this. To make this work, the update method needs to match this signature exactly, like this. So now each observer can register its update method with the subject, like this. When the subject calls the notify event, all the observer's update methods are called. If you have the subject put the new state in the data value, then you do not need to make that second method call to retrieve the state. And if you connect one observer to several subjects, it can use the first argument to tell them apart. Okay, let me show you a very simple implementation of the pattern. I will build a simple timer class that notifies its observers once every second. I'll add an observer that writes the current time to the console. I am going to use the following classes. Let's take a look at the code. So here is the timer class. It contains one public event field called notify. This is the event that will notify the observers every second. There's also a start method that uses a thread to fire the notify event once every second. And this is the observer class. It declares a method called update that matches the signature of the notify event in the subject. The method writes the current time to the console. So all we need to do now is register the console clock's update method with the timer's notify event to make the timer actually call the console clock. And this is where that happens. In the main program method here, you can see that I first instantiate the timer, and then the console clock, and then I attach the update method to the notify event, like this. This simple line of code registers the update method with the notify event. Now, every time the event fires, it will call the update method. Let me run the program to prove that everything is working. I'm compiling the code now, and I'm running the program now. And there you go. The current time appears once every second on the console. Everything works. Here is a quick checklist you can use to implement the observer pattern. First, identify the subject and observer objects. Then add a public event field to the subject. Add a public update method to the observer that matches the event signature. Have each observer add its update method to the event field. Have the subject call the event when the internal state changes. And finally, decide if you want the subject to push states to the observers or if the observers pull what they need from the subject. And here are some final comments. The mediator and observer patterns are very similar. Both decouple senders and receivers. The difference between them is that the observer pattern introduces more structure. In the observer pattern, all participating objects are clearly separated into two groups, observers and subjects. And therefore the pattern is less flexible but more reusable. You can also combine the mediator and observer patterns. In this combined pattern, the mediator object is responsible for object interactions, and you use the observer pattern to register, unregister, and communicate with participants. Okay, here is a summary of what we have learned in this lecture. The observer pattern defines a dependency between objects, so that when one object changes state, all its dependents are notified and updated automatically. The observer pattern is flexible and scalable, and it can easily deal with new types of observers. The pattern is slightly less efficient than the push model, and it may lead to memory leaks. The .NET framework implements the observer pattern with events. You can combine the observer pattern with the mediator pattern.